Okay, hello guys. Now I'm gonna to illustrate the question 2 to you guys. I'm so sorry. I can only hold my phone because I've tried to use the screen record but it cannot record my voice. So I have to take the video by myself. Okay, let's begin with the question 2.1. Okay, in this question we are gonna to verify the age is a symmetric matrix, right? So to prove this, we are gonna to prove H transform is itself equal itself, and the H equal to I. I is a identity matrix, right? Minus 2 multiple vector U and U transform. So H transform is I transform minus 2 U transforms. The identity matrix transform is itself, right? And this part, because U multiple U transform is an outer, right? So its transform is still itself. So it's still 2 U transform. So we can see into the picture, like the H is just equal to itself. So the H is symmetry. Okay, now we go to the question 2.2. The question 2.2. In this question, we are gonna to prove that H is orthogonal, right? To do this, we are gonna to prove H transform H equal to identity matrix. So from last question, we have know that the H transform is just itself. So it's gonna be I minus 2 vector U's transform, I minus 2 U transform. And this equation is gonna be I minus 2 U transform minus 2 U transform plus 4 U transform U transform, right? Look at this part. Look at this part. From the very beginning, we have known that the U transform. The U transform multiply U is exactly 1. So this equation is gonna be it's gonna be I minus 4 U transform plus 4 U transform, and it is exactly identity matrix. So it's obviously like H is orthogonal, right? Okay, it makes sense. Now we go to the question 2.3. In this question, we need to verify vector U is an eigenvector of H, and we also need to find an eigenvalue associated to U. To do this, we just need to prove this equation, like H minus lambda I right? And the lambda is the eigenvalue associated to the eigenvector u. And this equation is gonna be hu equal lambda u, right? Now we take the h to its expression. And this is gonna be u minus 2 u transform u. This part is 1, right? So it's gonna be minus u equal to lambda u. So it is very obvious, like lambda equal minus 1. So u is an eigenvector of h, and the eigenvalue is minus 1. And the last question, and the last question is question 2.4. Technically it do the same. The only difference is we introduce a totally new vector v. The vector v is a vector also orthogonal to u, which means that u transform multiple vector v is 0. Sorry, it's 0. So we just need to repeat what we do in last question. Here, the lambda 1 is also the eigenvalue associated to the vector v. The following step is quite simple. We just do what we do again, right? And look at this part, because they are orthogonal, right? So this part is 0. So we have v equal lambda 1 v. So it is very obvious that the lambda 1 is 1. Okay, we have finished. Thank you for listening.